So if I was to look at that, it says Daisy buys a torch and a battery. So I might write something like torch, add battery. And it says the torch costs 8 times as much as the battery. I'll worry about that bit of information in a moment, okay? It says Daisy pays for the £20 notes and gets £15.86. And when I was doing it, I very, very, very nearly wrote down equals £15.86. Can anyone tell me why that would be wrong? It's the change, okay? So just be careful with the wording there, because I'm dyslexic. I very, very nearly always fall for things like that, okay? It says that she paid with £20 and she got that much change. So I need to do 20 take away 15.86, okay? And I think that comes to £14.14 off the top of my head, okay? So that equals £14.14. Now I can use this other bit of information at the start where it says the torch costs 8 times as much as the battery. Now, what your sort of default position will be to say, all right, divide that by 8 because of it being 8 times as much as the battery. But what I did was I said, if the battery, if I'm going to call that B, then what would I call the torch? Would I call it T? If I called it T, I've got 2 different letters, and I'm going to find it too hard to solve anything. Because I know it's 8 times as much as the battery, what I'm going to write is 8B. Okay? And that's going to be equal to £4.14. Can anyone spot what I do next? No ideas? 8B add B? 9B. Equals £4.14. Any ideas on the next bit? How would I get rid of that 9 to find the price of the battery? Excellent, divided by the 9. So the battery would equal £4.14 divided by 9. Anyone help me out there? I don't know if I can do that in my head. 46p?
Yeah.
Is it? I'm only remembering what I wrote down before. Don't worry, I can't do that in my head. I'm not expecting you to do it in your head. I'm expecting you to use your calculator because we've got a calculator for this exam, okay? So I think it comes to 0.46, but that's in pounds, so in other words, 46 pence. Okay? But I did feel that the wording of that wasn't as nice as it could have been. If you divided by 8, you did the common misconception. Okay? Okay, so over the page, we had a question on scatter graphs. And the key to actually doing this question successfully was working out the missing scales. So before I even start trying to do too much of this question, I'd work out how much one little square is going up this way. Does anyone know how I'd work that out? Because my class in November, we need to just go over this to make sure we're really, really happy with it. The way that you do it, you look at this first number here, which is 1. So I've gone up 1, but how many little squares fed into that 1? 1, 2, 3, 4, 5. So if I do 1 divided by that 5, I can put that into my calculator. So 1 over 5 equals, I'll press SD and I get 0.2. So that tells me that one little square is worth 0.2. Okay? Now you've got an awful lot of points to plot here, and it is worth 2 marks for plotting the points, so take your time. The 2 marks are definitely doable. Oh, the other scale going up here as well is the same, isn't it? It's 1, and then it's 5 little squares, so it would be 1 divided by 5, which again is 0.2. Okay? So I need to plot all these points here. So 6.8, I'd actually come to 7. Find 2.4, so there's 1, there's 2. That's going to be 2.2, 2.4. But that's on 7. To get to 6.8, I'm going to go backwards 1 square. So there. And I just tick off underneath it so that if I do get distracted, I hear someone coughing in the exam or drop my pen or whatever, I can see which ones I've already plotted rather than having to think, hang on, have I done this one and done this one, okay? So then 7.4, so again, sticking on the 7, I'm looking for 2.6, so it's there. And then 1, 2, that would be 7.4. 7.2 and 7.4 by there. So they're really close together, the first 2 points. Then 3.2, so I'm going along 3, finding 1. There's 1.2, then 3.2, 1 over. 8.2, so going along the 8 line until I get to 3, and then because it's 8.2, I come 1 square over. 9.4, again, same trick. 9 up to 3, then 3.2, 3.4, but that's on 9, so then 9.2, 9.4 by there. And then 7.6, so I'll probably stick along with 7 for that one. There's 2, 2.2, 2.4, 2.6, 2.8. And I needed to go across to 7.6. I'm on 7, so 7.2, 7.4, 7.6, so really close again to what I've already plotted. 4.2 and 1.4, so I'm going along 4. There's 1, 1.2, 1.4, and then 4.2, which is what I need to plot. So it's 4.2. 2.8 and 1, so I'm actually coming to 3, going up to 1, but to get to 2.8, I'm actually coming back 1 little square to get to 2.8. And then finally 8.4 and 3.2, so here's 8, here's 3, 3.2, and then come across 8.2, 8.4, so again really, really close. Okay, so you're looking at 2 marks just for taking your time and plotting it. If it takes you longer than 2 minutes, I'm not too bothered because they're 2 quite accessible marks, I think, for everyone in here. Okay, by eye, draw a line of best fit. Now, I'd always do this in pencil first and then go over it in pen if you wanted to stand out afterwards. Because if I do it wrong in pen, it's going to ruin all my work. Now, a line of best fit, it doesn't have to go through this point here, the origin, 0, 0. It's a common misconception. People join it up to there. If it doesn't go through there, it doesn't go through there. You've just got to follow the general trend of the data. So what I do is I picture, if I had to carry on predicting where these are coming, I'd assume they're going to carry on around here somewhere. So I try and get my ruler to go through that point there, and I try and get the same amount of points beneath the line and over the line. So I'm going to try and do something like that, but then I may reassess after. And if I join up, if it goes through 0, 0, it's just a coincidence. So can you see mine doesn't? That doesn't mean it's wrong. We happy with my line of best fit? I think I'd get away with it in an exam, but if I was being really, really, really fussy, I've got 1 point just above the line, and then maybe 3 points just above the line and none below it, so maybe it should be like a millimetre higher. It says state the type of correlation is shown in your diagram. So you've got 3 types. You've got positive, negative, and no correlation. Anything that you can tell me which one it is?
Positive.
Good. Positive always rises from 0, 0 and goes up in a diagonal. Negative does the opposite of that, so it goes from the top, comes down to here. No correlation, they're just everywhere. There's no pattern at all, okay? So it is a positive correlation. And then for part D, you need to use your work from what we did with that line of best fit to find the maximum length. So it says another leaf from the same tree has a maximum length of 5 centimetres. Use your line of best fit to find the maximum width of the leaf in this tree. So what I do is I find 5, I come up from 5, there, it hits my line, and then I come across there and read off what that value is. Okay, so I know each little square going up here is worth 0.2, so that is 1.2, 1.4, 1.6, 1.8. But it really doesn't matter if you've messed up your line of best fit. You will still get the mark for reading off your line of best fit and showing what you did. So even if your line of best fit, you didn't get that mark, that doesn't lose the mark here. Okay, so it's really important you show that line going up from the 5 and the line coming across. Okay, so there we go, I wrote down 1.8 there. Okay?
So like any...
Yeah, absolutely fine. Yeah, absolutely fine. So 1.6 would have been good, 1.7 would have been fine. It all depends where it actually comes off your line. So say I wrote down, say the answer in the mark scheme said 2.4, and I'd done my line of best fit wrong. The fact that I've read off this line of best fit and still got 1.8 would still get me that mark. So it's really important you show what you're doing for that bit, okay? Over the page for number 3. Now for this term, in terms of factorising, what you do to get something factorised, you put stuff into brackets. There's loads and loads and loads of different answers. I think, Lloyd, you've got my paper there. Can you find number 3 and shout out some of the ones I had? 2.
Bracket 6x squared minus 24.
Good.
6. 2x squared minus 8x.
2x squared minus 8x, yeah.
12x x minus 4.
X minus 4. Okay, right, I'll stick with those ones at the moment. There's a few others you could have had as well. Only one of those is truly factorised. Any idea which one?
The third one.
The third one, why? You're right, it is the third one. You would still get 1 mark for doing these, but they're not truly factorised, because to be truly factorised, you've got to have the biggest number outside here you can possibly get. So the biggest number that goes into 12 and 48 is 12. Is there a letter that goes into both? Can you see I've got x squared and x in there, so I need to have the x outside as well. We call that the highest common factor there, HCF. Have you heard that term before? So you're always looking for the biggest number to come out of there, and then in here, x minus 4. And that would get me the 2 marks. If I did one of those ones, I'd drop a mark. Okay, now, the way I do substitution, I'm going to really be pushing this in future lessons. What I'd recommend that you do is you just change that x to open brackets. Okay, so that's all I've done so far. I've just seen where the x is and changed it to open brackets. And that's because I'm told what the value of x is. So what I pop in here now is that minus 5 inside the brackets. So when I put that into my calculator, it will always work it out doing this method. So 2 minus 5 cubed comes to minus 250. If you don't put it in that format, you may well lose your bid mass marks, because your calculator will put it in terms of bid mass and it may not realise that minus belongs to it. Okay? So I'd always change the letter for open brackets and then just pop in whatever that letter says. Okay? And for the next one, I'm going to do exactly the same thing. You see it says A minus B over 8C. I'm going to change that to open bracket minus open bracket all over 8 open bracket. That's all I've done. A is 25. So where A is in here, I pop in 25. B is minus 3. So where B is, I pop in minus 3. And C was 7. And that just goes straight into my calculator. There's no working out to be done here, and that's the beauty of using this method. So first thing I'll do is press this button to get the fraction, and then it was brackets 25, close brackets, minus brackets, minus 3, and then over 8 brackets 7, and I get the answer half. Okay, that's all you need to do. You just need to change the letter to open brackets, and your calculator will always do the hard work for you. You don't have to do anything then.
So it says to write it as a decimal.
Write it as a decimal. Very, very well read. So to write it as a decimal, what is a half as a decimal?
2.
Fantastic. Well done. I didn't spot that. I would have got 2 marks for leaving it in that format. 1 for showing I subbed in the numbers, 1 for getting a half, 1 for getting 0.5. Okay? Well done. Well reading. Good reading. Question 4, I felt was a bit mean. They usually write it in a really nice table and you add a couple of columns to it, but I think you will have seen this before. When it says estimate the mean, what we have to do is try and, we can't actually give a specific answer. We can't say, like, if I worked out the mean age in here, I'd add up everyone's ages, including mine, including Mrs., and our average age would come out to being something like 17, which would be a really weird average this class. Why would that be a really weird average?
Because it's 2 really high numbers.
There's two really incredibly high numbers. Yeah. Obviously my age, but not quite as big as Mrs. age, which is obviously much more than mine. And that extreme value really pulls up the average of our age in here. Okay. Now I can't really do that here because I'm given like what's the word I'm looking for? Like a range of values. So it says somewhere between 0 and 5. So where's the best place to say then between 0 and 5? If I had to guess an age, or if I had to guess a temperature in that scale, where would be a good place to guess between 0 and 5? Excellent, 2.5. We call that the midpoint. Okay? Midpoint, or MP, is absolutely fine to just write that there, but we're used to seeing this table actually being paired like underneath each other rather than just one long skinny line. So 2.5, and then in between 5 and 10? Excellent, well done. If you're ever unsure about what the midpoint is, the best trick I can tell you to do is you do 5, add 10, so you do the first number, add the last number, press equals, and then halve it. Divide it by 2, and it will always tell you when you press SD what the midpoint is. Okay? So say it was something like 18 and 27, you're like, don't know what's in the middle of it. You just do 18 plus 27, press equals, divide it by 2, and you get your answer. Okay? But obviously we haven't got that one this time. Middle of 10 and 15? 12.5, someone told me the next one, 17.5. And the last one, 22.5. So, in terms of how many days did we have where the temperature was 2.5 degrees? None. So the answer is going to be, we do a new column here, sorry, called MP times frequency. So 0 times 2.5 is just going to be 0. There's no days where it was that temperature. There were 5 days when it came to 7.5 degrees. So I'm going to do 5 times by 7.5, which comes to 37.5. There are 9 days where it was 12.5 degrees. So 9 times 12.5 comes to 112.5. And there were 17 days where it was 17.5 degrees. So 17.5 times 17 comes to 297.5. And then there were no days where it came up to 22.5 degrees. So that's going to be 0. Trick question. A little bit sneaky putting those in. They don't usually put in zeros there. Now to work out the mean, we add them all together and divide by how many. Well, how many days were there in July? 5 plus 9 plus 17. Put it into your calculator if you're unsure. But it's 31 days in total. 31 days in total. Okay? In terms of what the temperature was, I need to do 37.5, add 112.5, add 297.5. So if I just do that over here.
447.
Oh, top man, was it 447.5? So to work out the mean, it's always what they added together divided by the total. So that's 447.5 divided by 31. 14.4 is a really long, horrid number, isn't it, Andrew?
Yeah.
So you round that to one decimal place. It didn't say to do that, but obviously it's not going to be advantageous for us to be writing down a really, really long number that keeps on going on and on. So I agree with Andrew by rounding it to 1dp, but I must say I've rounded it to one decimal place. Okay? Explain. Oh, go on.
Would you lose marks if you didn't say 1D?
I don't think you would. Out of the 4 marks there, I want to see you get 1 for doing the midpoint column, 1 for doing the midpoint times the frequency, 1 for adding them together, and 1 for dividing by 31.
It's good to get in the habit of doing it, but it wouldn't take a mark off you. But
Yeah, so if you come out of the exam, don't worry about things like that. It's not the end of the world.
if you did that sort of thing in the QWC question, they could take a mark off you. Okay, so that's why it's worth getting in the habit of doing it. Okay. Okay.
The next one, these ones are always pretty difficult to explain and pretty difficult to get your head around. And for me, it's a sort of one, because it's only 1 mark, I wouldn't say, look, don't stress out about it if you don't get it. If you get it, great, you put another mark into your mark bank. But if you don't get it, don't stress out about that, okay? It's not the end of the world losing 1 mark here and there. Modal group, the word modal, sorry, let me show you the paper, just tell me if you can't see what I'm doing. Modal group means mode, meaning most common. The one with the most amount in it. Now the incorrect thing to say here, the modal group, is 20 to 25 because it's the most. We're not talking about the most in terms of the highest numbers, we're talking about the most in terms of the biggest number of people who are in it, or the highest frequency. Okay? So the modal group here is 17 because that is the biggest frequency, but that 17 belongs to 15 to 20. So I'd say because 15 to 20 has highest frequency. Okay? And again, I felt this question was a little bit sneaky. It said, what is the maximum possible range of temperatures recorded by, I can't even say a name, Iona? We'll go with that. If you look at this thing here, you would be right to think it is 25, take away 0. That is the right thing to think, because the highest number there is 25, take away 0. But there's probably a suggestion in my voice saying that there's not that. Is there anything they can tell me? Go on, Andrew.
Can I take away 5?
Why?
Because they're the highest one with the numbers.
Fantastic. There's nothing recorded here. So the highest number could have only possibly been 20, and the lowest number, there's nothing recorded here. So the lowest number must be 5. Well done. I didn't think that was obvious, so well done. So that is going to be 20, take away 5, which is 15. All good? Over the page, and again, I didn't think this was particularly nice. An awful lot of text. As soon as I see lots of text, I get my back up and think I don't really like these ones here. It says Dewi lives in another place I can't say. He recorded the midday temperature in degrees Celsius in July last year. He decided on groups for recording his temperature. From his group data, he worked out the estimated mean was 18.2 degrees. The modal was 10 to 20, and the range was 8. Dewi decides to compare his averages and the spread of data with Iona's data. Okay, so they've told us what the modal group was. Estimated mean, you don't actually have to write this in. There's not a mark for writing it in because we've already done it, but I can go and put in that it's 14.4. It says, why might Dewi choose to use the estimated mean rather than the modal group to compare the data? And again, I didn't think that answer was obvious. The answer that I went for was because the mean has a specific value. Whereas I think if someone said to me, oh, the average temperature in July last year was between 10 to 20, or the average temperature in July was between 15 to 20, if someone just tells you what it is, that would be a bit more of interesting actually. You can take a bit more note from that. 10 to 20 degrees is quite a big range. You can't really say anything about. It's been 10 to 20 in December. It's been 10 to 20. Well, it's been less than that because it's been cold recently in January, isn't it? But it doesn't really tell us much. But we have had some warm days in January. Okay? And then for the final one there, it says, why might Dewi find it more useful to use the estimated mean rather than the maximum range to compare the data? The range doesn't really tell us anything about the temperature, it just tells us the difference between the highest and the lowest temperature. So the fact that we just getting told the difference between the biggest and the smallest number doesn't really tell us what the temperature is. So I'd say something like, the range tells us the difference between max and min temperatures rather than what the temperature was. But I've got a feeling I wrote down a different one in my answers. Lloyd, have you still got my answers there?
Not miscounted.
What did I say before, miss?
Range doesn't tell you how hot it is.
Okay, so yeah, range doesn't tell you how hot it is. So for instance, if we looked at the range of temperatures in January already, you'd say it's been a range of 10 degrees. You could say the same in August. The range between the highest and the hottest and the coldest day in August was also 10 degrees. It didn't tell you how hot it is. Okay? Maybe that's a quick way of writing down. This is sort of like a version of that, but it's a bit longer. Okay? We have a go at doing one more question and we'll stop for a break. Okay, finally then, so for C, it says, right, the key words here, it says use the graph paper below to draw a frequency polygon. That word frequency polygon should tell you two things. A frequency polygon fundamentally is a line graph, but you must plot it at the midpoints. If you don't plot it at the midpoints, you will lose one of your 2 marks, okay? So when I'm looking at that, I've got to find my midpoint. So the same ones that we worked out before, 2.5, 7.5, 12.5, 17.5, and 22.5. I need to go and work out this scale. So the first number is 5. How many little squares feed into that 5? Good, thank you for saving me a job. Can we see there 10 little squares go into it? So 5 divided by 10, be careful. Common wrong answer here is 2. 0.5. Put it into your calculator, it's fine. You've got a calculator on this paper. So that tells you that 1 little square is worth 0.5. So that means a whole would be worth 2 of the little squares, okay? So at 2.5, so I'm just finding in the middle of 0 and 5, so that's the 5th one here. I need to plot 0, so that's easy, just on the axes there. The next one, 7.5 and 5 is fine, because 7.5 is in between 5 and 10, and then 5 is a nice bold line for me to find. But here's my first one that's difficult to plot. 9, now if I go to 5, I've got to count up loads and loads and loads of little squares. I would go up to 10 and count backwards. So 12.5 here, here's 10, that would be 9.5, 9, so it's 2 little squares down from 10. The next one, 17.5 and 17, so here's 15 to 20, so 17.5 in the middle. And then 1, 2, that would be 16, and then 1, 2, that would be 17, so there. And then finally back to 0, so 22.5 in the middle there. And then, because it's a line graph, I just join them up with a ruler or something that can draw straight lines. Okay? That's a good place to stop now for a break, okay?